Hello students, today we will discuss about the light, reflection and refraction. Now what is light? Light is a form of energy. It is the form of energy and it brings the sensation of sight. Ray. What is a ray? Ray is the straight line. Ray is the straight line indicating the path of the light is called ray. What is beam? A bundle of rays. That is the bundle of rays originating from the same source of light is called beam in a particular direction of the light. That is the bundle of the rays originating from the same source of light in a particular direction of light is called beam of light. Here are the different type of the beam: parallel beam, convergent beam, divergent beam. Parallel beam. When the rays which constitute the beam are parallel to one another, these rays are parallel to one another is called parallel beam. Convergent beam. When the rays are actually meet or appear to meet at a point is called convergent beam. When the rays are actually meet or appear to meet at a point is called convergent beam. Divergent beam. Divergent beam. When the rays are actually diverge or spread or appear to diverge from a point is called divergent beam. These rays are diverging from the one point and these are called divergent beam. Reflection. Now what is reflection? Reflection. When light falls on a surface and gets back into the same medium, it is called reflection. Reflection is what? When light falls on a surface and it gets back into the same medium. It is called reflection, or simply bouncing back of the light is called reflection. A highly polished surface or the mirror reflects the light. Only highly polished surface or a mirror reflect the light. When we study about the reflection, then we will discuss about the incident ray. Incident ray, the ray of light which fall on the reflecting surface. This is the ray of the light which fall on the reflecting surface. We will explain about the how reflection takes place. For reflection, take a plane mirror. Its one side is polished, and when a ray of light fall on the reflecting surface, this is reflecting surface. Reflecting surface or a mirror, reflecting mirror. When a ray of light fall in it, this is called incident ray. This is called incident ray. And then it reflect back or bounce back in the same medium. This is called reflected ray. Reflected ray. And a perpendicular along the reflecting surface. This is called normal. This is called normal. Now what is incident ray? Incident ray that fall on the reflecting surface is called incident ray, which is incident on the reflecting surface or mirror. That is incident ray. And the ray which get reflect back or bounce back, this is called reflected ray. And the perpendicular along the reflecting surface is called normal. And the angle between the incident ray and normal. Angle between the incident ray and normal is called angle of incidence. Angle of incidence is angle between incident ray and normal, and it is represented by the angle I. Angle I is the incident ray, incident angle, and here is angle of reflection. Angle of reflection is represented as or defined as the angle between the normal and the refracted ray. Angle between the normal and reflected ray. This is called angle of refraction R, and this is called angle of refraction, angle of incidence I. Now the laws of reflection. Laws of reflection. First law, look at here. First law, incident ray, reflected ray and normal all lie in the same plane. First law is incident ray, reflected ray and normal all lie in the same plane. Now the second law is angle of incidence is always equal to angle of reflection. Angle of incidence is always equal to angle of reflection. This is called second law of reflection. It always, if it is 30 degree, then it will always 30 degree. If it is 40 degree, then it will always be 40 degree. Angle of incidence always equal to the angle of reflection. Discuss about the image. Image is the point of convergence or point of divergence. Convergence means meet at the point and divergence means spread at the point. After reflection is called image, the point of convergence or point of divergence. After reflection is called image. Image is of two types, real and virtual. Real image. Real image is formed when the light rays actually meet. When the light rays actually meet or converge after reflection, that is obtained on the screen. This real image is obtained on the screen and it will always be inverted. It is obtained on the screen and it is always inverted. It is formed by the both convex lens and concave mirror. Real image is always formed by the convex lens and concave mirror, and size of the image depend upon the position of the object. So it can be diminished. Diminished means very small, same size, or enlarged. Enlarged means very large. Now the virtual image. Virtual image, it is virtual, not actually formed. It is formed when the light rays appear to diverge after reflection. It cannot be obtained on the screen. It cannot be obtained on the screen, and it will always be erect. It will always be erect. It is formed by the concave and convex lens and concave and convex mirror, and also with the plane mirror. Now plane mirror. Plane mirror always form an erect, virtual, same size, laterally inverted image. Our image, when we see in the plane ourselves, then it will be erect, virtual, same size and laterally inverted. But at the back of the mirror, we feel that we are at the back of the mirror. Its magnification is +1. Now the important terms associated with the mirror. First is aperture. Aperture, the width of the reflecting surface. Width of the reflecting surface. This is the reflecting surface, and this width is called aperture. The width of the reflecting surface from which reflection takes place is called aperture. Now the pole. Pole, the central point of this reflecting surface. Central point of this reflecting surface is called pole, and it is denoted by the P. Now center of curvature. Center of the hollow sphere of which the spherical mirror is a part. If we complete the circle of the mirror, then the center of the center of the hollow sphere of which the spherical mirror is a part. This spherical mirror is a part of this whole sphere, and center of this is called center of curvature, and it is represented by the C, or it is denoted by the C. Now this is the aperture. Width of the mirror is aperture, and at the center of this reflecting surface is pole, and this is the center of curvature C. Center of curvature C. It is the center of the sphere if we complete this sphere. Now the radius of curvature. Radius of curvature. Radius of curvature is the between the pole and center of curvature. It is between the pole and center of curvature. Now if we join this line, this is called principal axis. This is called principal axis. Is focus. Here where the rays after reflection converge or diverge. This point is called focus. Focus. This is called focus, where the point on the principal axis where beam of light parallel to the principal axis actually meet after reflection or appear to come from this is called principal focus. Focal length. The length between the pole and the focus. This length is called focal length. This is called focal length. Again, I am recalling this width of the mirror or reflecting surface is called aperture. This is called aperture. And the center of this aperture is called pole. Pole. And the center of this sphere at which the surface, reflecting surface is the part of this mirror hollow sphere, and the center of this is called center of curvature. And the radius of curvature lies between the center of curvature and the pole. Now the focus. When the rays after reflection passes from the or diverge or converge from the point, that point is called focus. And the length between the pole and focus is called focal length, and it is denoted by the small f. It is denoted by the small f. Now radius of curvature. Separation between the pole and center of curvature is called radius of the curvature, and it is always equal to 2f, double of the focal length. Principal axis. The straight line joining the pole and center of curvature. The straight line joining the pole and center of curvature. Focus. The point on the principal axis where beam of light parallel to the principal axis actually meet or appear to come from that point. Now the focal length. Focal length is the length between the pole and the focus. And radius of curvature is always the twice of the focal length equal to the 2f. Now what are the rules to draw the ray diagram? What are the rules to draw the ray diagram? A ray of light parallel to the principal axis. A ray of light always move parallel to the principal axis. First rule is it will always move parallel to the principal axis. A ray of light parallel to the principal axis will pass through the principal focus of a concave mirror, and after moving parallel it will always move from the focus. It will always move from the focus. Ray of light passing through the principal focus of a concave mirror will emerge parallel to the principal axis. If a ray of light moves from the focus, then it will move parallel to the principal axis. Now the third is a ray of light passing through the center of curvature of a concave mirror retraces its path after reflection. If a ray of light passes through the center of curvature, then it will retrace its path in the same medium. That is, these are the three rules. First is the ray of light parallel to the principal axis will pass through the principal focus, always move from the focus, and after passing from the focus, it will emerge parallel to the principal axis. And third is the after passing the center of curvature, it retraces its path after the reflection. We will draw the various images formed by the concave mirror. This is the concave mirror. When the object is placed at infinity, F and C. When the object is placed at infinity, then first rule is rays will go again parallel to the principal axis, and then second is pass from the focus, and if pass from the focus, then move parallel to the principal axis when the object is at infinity. Then image formed is real, inverted and diminished. Real, inverted and diminished. This is the image. Now, when the object is placed beyond the C, starting from here, this is the image object. You can take the object as a tree, candle or any arrow you can suppose, or any other object you can take. Then according to first rule, the rays goes parallel to the principal axis, and then according to the second rule passes through the focus and then center of curvature. This is the image. This is the image. Real, inverted and small size. Small size. This is the size of the object and this is the size of the image. It is shorter than the object. Now, next image, when the object is placed, first is at infinity. At infinity, second is beyond C or before C. Before C or beyond C you can say. Now, beyond C, then we will put at the C. At C. Now, according to first rule, rays goes parallel to the principal axis, then pass to the focus and then pass to the center of curvature, and after the passing the focus, it will goes to parallel to the principal axis, and then the image formed is real, inverted and same size. Same size. You can see the image formed is, this is the object and this is the image. This is real, inverted and same size of the object. Now next image is when the object is placed at, you will mark here polished surface and mark the arrow for the movement of the, to show the movement of the ray. Now object placed first at infinity, then C, beyond the C, then at the C. Now after, between, you can say three positions, between C and F, when the object is at between C and F, or when the object is after the C, or when the object is before the F. You can take all the three positions same. First goes to the parallel to the principal axis, then passes from the focus and then passes through the center of curvature, and the image is formed. And you can see when we move the object, towards the reflecting surface, similar way image is moving first at the infinity, then when we take before the C, then it will after the C, then we take at C, then it will be C, and when we take before the C, then it will, object is the after the C, then image is before the C, and image is real, inverted and large size, or you can say enlarged. This is the movement of the rays. This is image. This is image. Now where we put the object now? At C. After C, now we will put the image at focus. Image object as the focus. When we put the object at focus. Object at focus. Fourth is the between C and F. C and F. Now at the focus. According to the first rule, it will go parallel to the principal axis, then passes from the focus, then passes from the center of curvature, and it will look like meet at infinity. Image is real, inverted, and large size, highly enlarged. Now the next is when the object is placed at the after F, we will place the object in between pole and focus, or after the pole and before, after the focus and before the pole. Again I am repeating, when the object is after F or in between F and P and before the P, that is pole. Now first is going parallel to the principal axis, then passes from the focus, then passes from the center of curvature, and it will look like meet behind the mirror. And this only you can see. Object is standing, image is also standing. It means image is erect, virtual, it is behind the mirror, not obtained actually on the screen, and highly enlarged. Highly enlarged. Erect, virtual, and highly enlarged. These are the image formed by the concave mirror. We will discuss about the convex mirror. Convex mirror. If you complete the sphere, then the focus and center of curvature of the convex mirror lies on this side. Now, if we put the object at infinity, then first rule is it will go parallel to the principal axis and then passes from the focus. Then passes from the focus, and it is behind the mirror, just appearing dotted line and reflect back. Reflect back on this side. Now here the image is erect, virtual, and highly diminished. When the object is at infinity. Now in the second position, we will take the object anywhere. Here is F and C, anywhere we can put the object. Now first, according to first rule, it will go parallel to the principal axis, then passes from the focus and reflect back. Now passes from the center of curvature. This is the center of curvature, and image formed here because both the rays meet here, and the image formed is here, and it will go back. Now image is erect. You can see standing arrow just like the object, and size of the image is small. Object is large and size of the image is small or diminished, diminished, and it is virtual because it is behind the mirror. It is virtual. It is behind the mirror and not obtained on the screen. Now the concave mirror is used as a shaving mirror. It is used as a shaving mirror or the reflector of the concentrate light in a reflecting type astronomical telescope, in searchlight, headlight of the automobiles, and used by the dentist. Concave mirror used by the dentist also to see the clear images. Convex mirror is used as a rear view mirror. Rear view mirror in automobiles because in rear view mirror images, convex mirror give wider field of the view as mirror is curved outward, and it produces the erect and diminished image of the traffic behind the driver of the vehicle. That's why convex mirror is used as the rear view mirror because it gives the wider field and produce the erect and diminished image to the driver. Now the mirror formula. It is equal to 1 by f is equal to 1 by v plus 1 by u. F is the focal length. F is the focal length. V is the image and u is the object. Now magnification. Magnification is defined as the ratio of size of the image to the size of the object. Size of the image to the size of the object. M is equal to magnification is equal to height of the image by height of the object. Height of the image by the height of the object. That is height of the image I and height of the object HO. That is height of the image is minus V and that is object is U. Now magnification is negative for real and inverted image. Magnification is negative for real and inverted image and positive for the virtual and erect image. When will you solve the numerical? You will put the sign plus or minus. Magnification is less than 1, then image is diminished. Image is diminished when magnification is less than 1. And when more than 1, it is highly enlarged. And equal to 1, then it will be the same size. Thank you.